Greetings everyone and welcome to question number 8 of YÖS examination mathematics 1 section. For this question we have chosen a question which was already asked in YÖS examination in the year 2013. So let's see what the question asks us and what is the process we need to follow to get to the right answer. In this question we have x over 3 which is equal to y over 5 which is equal to z over 8, and we are given x minus 2y plus z which is equal to 3, and we are asked the value of y. So since we are dealing with proportions and ratios, what we can do, we can use the trick of the unknown variable. If you want to find more information about the unknown variable, you can also visit our lectures where in detail we explain the process you need to follow when using this unknown variable. This trick which can save you a lot of time. So we will do the same here. So what is x equal to? X is equal to 3k. Let's just put it k. K is the unknown in this case. So what we did, I just equal the numerator of this fraction, I made it equal to the denominator, and I multiplied with an unknown, which I don't know, k, what k is equal to. I'm gonna do the same thing with all the units here that we have. So we have y which is equal to 5k, and we have z which is equal to 8k. Now I'm going to apply these values in the equation that we have, which is x is 3k minus 2 times 5 is 10k plus 8k, which is equal to 3. So 3 minus 10k it's minus 7k plus 8k it's k, which is equal to 3. So we know the value of k now, 3. We are asked the value of y. We know that y is equal to 5k, which is equal to 5 times 3, which is equal to 15. So the right answer for this question is 15. As you can see, very easy, very simple, a trick that can help us save time in our exams. Greetings everyone and welcome to question number 9 of YÖS examination mathematics 1 section. In this question we have 2 to the power of 2002 plus 2 to the power of 2001 plus 2 to the power 2000 over 2 to the power of minus 2004 plus 2 to the power of minus 2003 plus 2 to the power of minus 2002. So what is its value? What is this fraction's value? What do we do in this case? We see that both in numerator and denominator we have numbers with the same base but different powers, different exponents. So what do we do here? We try to take the common factor. As we take the common factor, we will be able to simplify this fraction. So what do we take as a common factor? As a common factor, we always take the number with the lowest exponent, which in this case is 2000. And the only reason we are doing is because the base is the same. We open the parentheses, this is times. Now 2 to the power of 2000, what will be the number, the leftover, let's say within the parentheses, it will be 2 to the power of 2. Why is that? Since we have the same basis, we have multiplication, we have said already that the exponents add each other. So 2 to the power of 2000 times 2 to the power of 2, it will bring us to 2 to the power of 2002. So now we will follow the same logic for the rest of the questions. So we have plus 2 to the power of 2001. Here we have 2 to the power of 1, because as you can see, exponents add, and this is of course 1. We follow the same logic now for the denominator, so we take the number with the lowest exponent, which is minus 2004, that is times, so we have 1 plus 2 times 1, 2 to the power of 1 plus 2 to the power of 2. As you can see, we just take the difference. Now what do we see here? We see that we have the same parentheses, the same numbers within the parentheses, so they cancel each other because we have multiplication. Now what is left is 2 to the power of 2000 over 2 to the power of 2004. When we have a fraction, we said that exponents subtract each other. So let's do that. We have 2 to the power of 2000 minus 2 to the power, so we have here minus 2004. So 2000 minus 2004, because this is negative. So please don't forget, Even though you're subtracting, don't forget to leave the sign that the exponent has. If it's a negative exponent, keep it a negative, because that will change the sign. When you subtract a negative number, it will become a positive, and therefore you will not be able to get to the right answer. So please make sure you include it. So here we have 2 to the power of 4004, which is the right answer for this question. Greetings everyone, and welcome to question number 10 of YÖS examination mathematics 1 section. In this question we have 3 to the power of x times 5 to the power of y, which is equal to 45 to the power of y. And we are asked the value of x plus y over x minus y. So we are dealing here with exponents. But we have different bases here. We have 3 and 5, and here we have 45. So what do we have to do? We have to make sure that we look at what is another way of us writing 45, which will enable us to have the same basis on both sides. We can do that only by looking at this number's prime factorizations. So we have 45, we have 3, 15, 3, 5, 5, 1. So these are the prime factors of 45. So what is another way of writing this? So we have 3x times 5y, which is equal. So we can write 45 as 3 to the power of 2, all to the power of y, because we are given, times 5 to the power of y. What did we do now? We now managed to have the same basis on both sides. So here we have 3 to the power of x minus 5 to the power of y, which is equal to 3 to the power of 2y times 5 to the power of y. Now, since the bases are the same and we have the equal sign, we can also equal the exponents of the same bases. So here we have 3, here we have 3, so it means that x is equal to y. As we found the value of x, now we can just apply its value on what we are asked. So we have 2y plus y, which is equal to 2y minus y, which is equal to 3y over y. So y is cancelled, and the right answer for this question is 3.